Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in easy manner. In our IUPAC nomenclature, already we have did the lecture number 1, lecture number 2 and the lecture number 3 elaboratedly with the n number of examples and what are the rules to remember and what are the tricks to remember. Already I was explained in those lectures. If you have missed those lectures, please go and watch those lectures. Now in this lecture we are going to deal with the bicyclo and the Spiro compounds. Many of the students, by seeing the bicyclo and the Spiro compounds, they will skip and they will think any other compound they have given. But it is very simple if you identify the molecule, and it is very simple if you remember the three rules which I was going to say in this video. Now let's start before going to the bicyclo compounds, bicyclo compounds are, what is the meaning of bicyclo compounds? Bicyclo compounds. What are the bicyclo compounds? Here bicyclo compounds means when two cyclo rings are fused. When the two cyclo rings are fused are known as the bicyclo compounds. Clear? These bicyclo compounds are two types. Then one is fused. What is the meaning of the fused bicyclo compound? Now if you take the one cyclic ring and this cyclic ring is fused in this manner, this is a fused bicyclo compound. Next one is a bridged or else one. Clear? Now this is a bridged carbons. Now bridged bicyclo compound. This is bridged bicyclo compound. Then now this bridged bicyclo compound we can represent in this manner also. This bridged bicyclo compound we can represent in this manner also. How? Here 1, 2, here 1, 2, here 1, here 1, here this is bridged carbon, this is bridged carbon, this is bridged carbon, this is bridged carbon. Now this 1 carbon, 2 carbon, 1 carbon, 2 carbon. Now here one, in between the bridged carbons 1 carbon is there, right? In between the bridged carbons 1 carbon. Now again this 1 carbon, here 1 carbon. Now again this 1 carbon, again this 1 carbon. Now this same compound again we can represent in this manner also. How? We can represent in this manner also. Now in this manner also we can represent. Now you can see this is bridged carbon, this is bridged carbon. In between bridged carbon 1 carbon we are having. Now here we are 1 carbon, here 1 carbon, here 1 carbon and here 1 carbon. Clear? Now we can, this compound and this compound it is same, and this compound and this compound is also same, and this compound and this compound is also same. All the three are same. Any of the notation they can give. All the three are same. You should not get confused by giving any of this compound. All the three are same. Then here to write the bicyclo compounds, first of all, when the bicyclo compounds if they have given bicyclo compound 1 degree prefix, we say it as a bicyclo. 1 degree prefix for the bicyclo compound is bicyclo. Then how to write the IUPAC name for the bicyclo compounds if they have given? First one, here if the functional group if it is also present, that we can give high priority for the functional group also. But before to the functional group, which is a high priority? Ring is high priority. This is very, very important. Ring is a high priority in the bicyclo compound. Second point is very, very important. What is the second point? Second point you have to remember that longest carbon path is high priority. Sir, what is the longest carbon path? Means here if you see if I was taking this one carbon or this one bicyclo compound I was taking. This is a one bicyclo compound I was taking. For this bicyclo compound, better I will take this one so that you will not get any confused. Okay, here one carbon, 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 here one. Clear? Now here the longest ring is the high priority. Now give the numbering, choose any of the bridged carbon. Either you can take the one for this one, either you can take the one for this one. Any of the bridged carbon give the high priority. So this bridged carbon you give the 1, then after that numbering you have to start it from here or here. That it will be depend upon the substituent and it will be depend upon the ring. Clear? Here how to write the naming of this bicyclo compounds? I said you first is the ring is high priority. Next one what I choose, I said longest path of the carbon is high priority. See, if you want to go from this bridged carbon to this bridged carbon, here how many carbons we are having? 1, 2, 3. 1, 2, 3. If you want to go it from this bridged carbon to this bridged carbon, how many carbons we are having? 2. Here the longest carbon path is this one, right? 1, 2, 3. Then if you want to go it from here the only we are having only one carbon. Only one carbon. Means whenever you have chosen the carbon path, first you have to choose which one? Longest carbon path. Longest carbon path means you have to write here it is a large carbon path. Next moderate carbon path. Next one smallest carbon path. Smallest carbon path. These are the carbon paths. Clear? If you remember these 2 points, now you can write the IUPAC name for the any bicyclo compounds. Any bicyclo compounds. Clear? Now first, now we'll write the one IUPAC naming for the bicyclo compound. Now first if they have given this one. Now what I said, any of the bridged carbon you take it as a numbering 1. Now if I take this as a bridged carbon 1, now this is 2, this is 3, this is 4, 5 and 6, and the last priority will be given to the carbon which is present in between the bridged carbon. So this is 7. This is 7. This bridged carbon is 7. Now what I said to write the naming, first we have to write the 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix, right? Then 2 degree prefix it is absent because there is no any substituent in this compound. Then 1 degree prefix. 1 degree prefix for this bicyclo compound is bicyclo. After bicyclo, now mention the longest carbon path. Mention the carbon paths in the square bracket. See, if you go it from here to here for this bridged carbon, we are having only 2 carbons. So make it as 2. Then if you go it from here to here also we are having the 2. 2 comma 2. And if you want to go it from this bridged carbon to this bridged carbon, we are having 1. Here we are having 1. So make it as 1. So bicyclo 2 comma 2 comma 1. 2 comma 2 comma 1, then this is completed. Then comes to the root word. How many carbons we are having? Total 7 carbons we are having, right? Hepto, all are single bond. So this is heptane. This is heptane. Bicyclo 2 comma 2 comma 1 heptane. Bicyclo 2 comma 2 comma 1. Sorry. This is heptane. Clear? Done. Now this is a IUPAC name for this compound. Next. If suppose if they have given in this manner. Clear? If they have given this one. Now you see this is a bridged carbon. Now this is a bridged carbon. This is a bridged carbon and this is a bridged carbon. What I said, longest carbon path you have to choose. Longest carbon path you have to choose. Now this is, if you take this as a 1, now this is 2, this is 3, this is 4, this is 5, this is 6, this is 7 and this is 8. Then from this bridged carbon to this bridged carbon, if you are going you are getting only 2 carbons. If you choose this path from this bridged carbon to this bridged carbon, you are getting how many carbons? 1, 2, 3, 4. Clear? Now, in between this bridged carbon, there is no any carbon. Then there is no any carbon. Now, write the name. Naming will be bicyclo in the square bracket. Now, longest carbon path will be the high priority, right? Here, longest carbon paths, how many carbons we are having? 4 carbons we are having, so 4. Now, next followed by the moderate one. Moderate one, here we are having 2. Now, in between bridged carbon, there is no any carbon. So, it is 0. Bicyclo 4, 2, 0. If you want to represent the 0, you can. If not, it is also okay. Now, 4, 2, 0. How many carbons we are having total? 8 carbon, right? So, oct, all are single bonds, octane. That's it. Bicyclo 4, 2, 0, octane. Clear? Now, next. If suppose any substituents, if they have given for the bridged carbons, if any substituent they have given, then let's suppose this substituent they have given. Now, even though the substituent if they have given, now longest carbon path only you have to follow. Longest carbon path only you have to follow. Clear? Then longest carbon path only you have to follow, and substituent should get the least number. Means then you have to select that bridged carbon. Which one will give you the least number to the substituent? See, if I select this bridged carbon as the 1 and the longest carbon path is here. So it will be 2, it will be 3, it will be 4, it will be 5, and it will be 6, and it will be the substituent is 7, and it will be 8. Okay. Then if I choose the numbering for this bridged carbon as the 1, then it is 1, here it is 2, here it is 3, here it is 4, 5, 6, 7, and this is 8. Means if I choose the white numbering, substituent is getting 8. If I choose the orange numbering, now substituent is getting 7. So which is the correct one? Which is the correct? Orange numbering is the correct. Then now write the naming. How to write the naming? Same. 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Now substituent is present, right? Now which substituent is present? Methyl substituent is present. Now which position that methyl substituent is present? 7th position, right? So write 7 methyl bicyclo, 7 methyl bicyclo. Now mention in the square bracket. From this is the longest carbon path, right? Now how many? 1, 2, 3, 4. So 4 comma. Now here if you go, you are getting 2, 0. Clear? 4 2, 0. Because bridged carbon, there is no any bridged carbons between, there is no any carbon. Done. Next naming will be how many carbons we are having total? 8, right? Octane. Total octane. 7 methyl bicyclo 4 2, 0 octane. Done. Now next. Suppose if they have given in this manner, and the substituent here it is a Cl. Now what I said, now whatever it may be the substituent or anything it may be present, bridged carbon should be the last priority. Then you can choose the numbering here. 1, 2, 3, 4, 5, 6, and here it is a 7, Then how to write the naming for this one? 7 chloro bicyclo 2, 2, and in between bridged carbon 1 carbon is there, right? So 7 chloro bicyclo 2, 2, 1 heptane. Clear? Now this is a IUPAC name for this compound. Done. Next, let's suppose if they have given in this manner. In this manner, if the compound if they have given, then how to write the naming? Now select the bridged carbon. Now select the bridged carbon 1, here 2, here 3, here 4, and here it is a 5. Done. Now if you go one carbon, then the naming of this compound will be bicyclo. There is no any substituent, right? Bicyclo 1 comma 1 comma 1, because here one carbon, here one carbon, here one carbon. So 1 comma 1 comma 1 pent N. Done. Pent N. Clear? Now this is a naming of this compound. Now next. Let's suppose if they have given in this manner. Here the Br. Now here it is a methyl. Now if this type of the compound they have given, how to write the IUPAC name for this one? Here, now you see, select that bridged carbon, which one will give you the lowest sum rule or lowest numbering for the substituent. If I then first bridged carbon, high numbering of the carbon path, followed by the substituent. Then if I choose the numbering for this one, here 1, here 2, here 3, here 4, here 5, here 6, and here it is a 7. Substituents are getting 3 and 7 in the white color path. Done. Then if I go for the which one? If I go for the here bridged carbon 1, here 2, here 3, here 4, here 5, here 6, and here 7. Now in the yellow color naming of the path, what we are getting? 3 and 6. 3 and 6. 3 and 6 is the locant sum rule, right? So the whatever the numbering we have choose in the white color, it is giving the highest numbering. So the numbering is in the yellow color numbering, it is correct. Then how to write the naming for this compound? Then here bromo and here it is a methyl. Whenever you are representing the 2 degree prefix, root word and 1 degree suffix plus 2 degree suffix. Whenever you are representing the 2 degree prefix, you have to follow the alphabetical order, right? In that alphabetical order, first bromo will come, then after methyl, right? Now bromo is in which position? Third position. 3 bromo, next 6 methyl, 3 bromo, 6 methyl, bicyclo, 3 bromo, 6 methyl, bicyclo, 3 bromo, 6 methyl, bicyclo. How many carbons we are having? Total 7, right? Epto N. That's it. Clear? Now this is a compound. Sorry. Now 3 bromo, 6 methyl, bicyclo. Now how many carbons we are having? This longest carbon path. How many? 1, 2, 3. 3 comma. Now this longest carbon path. This is a next moderate carbon path. This is 2, right? 3 comma 2 comma 0. Epto N. Clear? 3 bromo, 6 methyl, bicyclo, 3 comma 2 comma 0, eptane. Done. Now this is a compound name. Done. Now next, if suppose if suppose here the Cl, if this type of the compound they have given, then how to write the naming for this one? See, if you go from this bridged carbon to this bridged carbon, 2 carbons only we are getting. If you go from this bridged carbon to this bridged carbon, we are getting 2 carbons only. Then which bridged carbon or which path we have to select? To select the path for this one, now substituents are also there. Substituent should get the least number, right? Then if you choose the numbering for this carbon, 1, 2, 3, 4, 5, 6, and the bridged carbon is the last priority, that is 7. Done. Clear? Here you can see 1, 2, 3. Substituent is getting 3 and plus 7. 3 and 7. Then If you choose the numbering from here, 1, 2, 3, 4, 5, 6 and 7. Substituent is getting 2 plus 7. 2 plus 7. Now this one is a correct numbering, right? Then write the IUPAC name for this one. How to write? This is ethyl, right? This is CH2. This is CH3. This is CH2 and CH3. Means normally it is a ethane. CH3, CH3. If you remove one hydrogen as a free valency, if you make by removing the one hydrogen and if you make the free valency, now this one we call it as a ethyl, right? This is a ethyl. Done. Now naming of this compound will be here the chloro and here the ethyl. Among the C and E, which one will come first? C will come first, right? Then write the name. 7 chloro, 2 ethyl, 7 chloro, 2 ethyl, bicyclo, 2 comma 1. How many carbons we are having? Total heptane. Total 7 carbons we are having. All are the single bonds. So heptane. Done. 7 chloro, 2 ethyl, bicyclo, 2 comma 1 heptane. 2 comma 1 heptane. Clear? Now next. Let's suppose if they have given in this manner. Done. Clear? Now this type of the compound they have given. Then how to write the IUPAC name for this compound? How to write the IUPAC name for this compound? Now you select. Here the one bridged carbon we are having. Here the one bridged carbon we are having. Now two bridged carbons we are having, right? In these two bridged carbons, now select that carbon chain or carbon ring which is having the highest carbon path. Here you can see here 1, 2, 3, 4. Here 1, 2, 3, 4. Both the cases it has same. Then after that, then select that bridged carbon. Which one will give you the locant sum rule for the which one substituent? Now if I choose this bridged carbon as a number 1, 2, 3, 4, 5, 6, 7, 8, 9 and it is 10. Clear? Then the substituents are getting 3 plus 5 plus 9. 3 plus 5 plus 9. Then if I go it from this bridged carbon 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now in the white numbering, now substituents are getting 2, 4 and 8. 2, 4, 8 is giving the locant sum rule, right? It is giving the lowest numbering to the substituent. Now this is the correct numbering. Now whatever the numbering we have chosen in the red, it is wrong. Then write the naming for this compound. Then how to write the naming for this compound? First you have to write the naming to the alphabetical order to the substituent. According to the alphabetical order, first bromo will come. At which position we are having? 2 bromo, next 3 ethyl, 2 bromo, 3 ethyl and 2 bromo and 8 chloro, next 4 ethyl, bicyclo, Now how many carbons we are having? 1, 2, 3, 4. Here also 1, 2, 3, 4. So 4 comma 0. How many carbons we are having? 10, right? So this is decane. 2 bromo, 8 chloro, 4 ethyl, bicyclo, 4 comma 0 decane. Clear? Now I will give you some compounds. Now try to solve those compound. Clear? Try to solve those compound and answer your answer in the comment section. If any changes it is there, I will answer over there in the comment section. Clear? Now here first simple compounds I will give you. Okay, done or else. Okay, this is a one compound, first one. Then second one. Okay, now this is a second one, and here we are having the one substituent chloro. Then third one. Then here it is a bromo substituent. Okay, now fourth one. Now next fourth one. Clear? Now here is a one compound. Then this is a one compound. Now try to write the IUPAC name for this one. Now last 5 compounds I will give you, so that it will be easy for you. Okay, now try to write the IUPAC names of these 5 compounds. Clear? Now try to answer those answers in the comment section. If any changes are there, I will cross check over there and I will justify your answer whether it is correct or wrong in the comment section. Clear? Next one we are going to see the which one? Spiro compounds. Clear? Now Spiro compounds. How to write the IUPAC name for the Spiro compounds? Done. IUPAC name for the IUPAC name for Spiro compounds. Now what is the meaning of the Spiro compounds? What is the meaning of the Spiro compounds? Now Spiro compounds is nothing but when two cyclo rings are attached, when the two cyclo rings are attached to one ring carbon is known as Spiro or Spiro compounds. Clear? For the one ring head carbon or one ring carbon, now the two rings if it is attached, that type of the compounds we call it as a Spiro. You take, this is one ring. Okay, now for this one ring carbon another ring is attached. Now this type of the compound we call it as a which one? Spiro compound. Done. Next, here in the naming of these Spiro compounds, now what you have to follow? First you have to follow that this Spiro, this bridged carbon or this interlinked carbon, when these two carbons are what? Attached, when these two ring carbons are attached, this carbon should get the least number. For that, here you have to follow, in the bicyclo compound we have followed from the high path to low path, right? Here in this compound we have to follow low path to high path. Here we have to follow lowest carbon path to highest carbon path. Okay, lowest carbon path to highest carbon path. Clear? Now when you have chosen the lowest carbon path, that what interlinked compound or this attached carbon should get the least number. Clear? Means here you should not start the numbering from the bridged carbon or this interlinked carbon. Here you should not start the numbering from the where this attached carbon. Here you have to start the numbering from that ring which is having the lowest carbon path to give. Here if you commit to here it is having the 2 carbons. If you commit from here also, here it is having the 2 carbons. Anything you can select. So this is 1, 2, now this is 3, and this is 4, and this is 5. This is 5. Now here the 2 degree prefix for this one will be the Spiro. This will be the Spiro. Now name of this compound will be Spiro 2 comma 2 comma 2 comma 2 comma. How many carbons we are having? Total 5, right? Penta-N. Penta-N. Done. Now you see. Next, if suppose if they have given in this manner, one compound they have given in this manner, then this is a attached carbons, right? 2 rings has been attached. Then you have to choose the carbon path that it is having the lowest first. If you commit from here to here, it is giving how many carbon paths? If I was started from here to get the attached 2 rings attached carbon, I was getting the here 1, here 2, here 3, and here 4. Then after from here to here, longest carbon path, right? Then it is 5, here 6, here 7, and here 8. Now this is a correct numbering. Correct numbering. Done. Then write the naming of this compound. Spiro, lowest carbon having 3 comma 1 2 3 4, 3 comma 4 comma 0, 3 comma 4 comma 0. How many carbons we are having? Total 8, right? Octane. Total octane. Then if suppose any substituent is present, then how to write the numbering for that carbon? If suppose in this manner, then here it is something one methyl will take, methyl substituent will take it. Here methyl substituent will take, or else ethyl substituent. From where the numbering will be started? Here if you start it from here this is the lowest carbon. Then now if you start it from here, now this is the highest carbon path. Done. Now lowest carbon path to highest carbon path, right? Then after that here the substituent is there. Then substituent should get the least number. Then numbering will be here 1, here 2, here 3, here 4, here 5, here 6, here 7, and here it is a 8. Done. Naming will be here substituent is there, right? At which position where the substituent is there? 1 position. So 1 ethyl, Spiro. How many carbons we are having? 2, and here 1, 2, 3, 4, and here it is 5. 2 comma 5. How many carbons we are having total? 8, right? 1 ethyl, Spiro, 2 comma 5, octane. Clear? Now the same compound, if another substituent, if it is present, if suppose here something chloro substituent it is there, then how to write the naming for this compound and how to choose the numbering for this compound, now we'll see. Here the numbering will be chosen in that manner. Here this substituent should get the least number 1, and here it is a 2, and here it is a 3. Then here 4, 5, 6, 7. If you go in this manner, this substituent is getting 7. But if you go in this manner, here it is a 4, and here it is a 5, here it is a 6, here it is a 7, and here it is a 8. Because substituent should get the least number, right? Substituent should get the least number. Then how to write the naming for this compound? Naming will be 1 methyl, 5 chloro, 1 methyl, 5 chloro. Sorry. Then you have to go on the basis of alphabetical order, right? Then it will be the 5 chloro, 1 methyl, 5 chloro, 1 methyl, Spiro. How many are there? 2 comma 1 2 3 4 5. 2 comma 5 comma 0. How many carbons total? Octane. This is a compound name. Done. Now let's suppose if any alkene if they have given. No. Here. No. In this manner they have given. Then how to write the naming for this compound? Then start. Here this is a lowest carbon, right? This is lowest carbon path. If you start the numbering from here 1, 2, 3, and it is a 4. Then if you start the numbering from here 5, 6, 7, 8 and 9. Here this what alkene, this double bonded carbon is getting 7 and 8, right? Then if you choose the numbering in this manner, let's suppose if you choose the numbering in this manner, here 5, here 6, and here it is 7, and here it is 8, and it is a 9. Here it is getting the 6 and 7 least number. Now this is a correct naming for this compound, or correct naming for this compound, or correct numbering for this compound. Then how to write the IUPAC name for this compound? Here this is a which one? Double bonded carbon, right? Ene, right? There is no any substituent. Then write Spiro. How many carbons we are having? 1, 2, 3. 3 comma, here how many carbon? 1, 2, 3, 4, 5. 3 comma 5, 3 comma 5. Total how many carbons we are having? Total carbons we are having the known, right? 9 carbons, right? Known, and it is a ene, right? And which position it is there? In known 6 in. Known 6 in. Clear? Spiro 3 comma 5, known 6 in. Done? Now, if suppose this type of the compound they have given, then how to write the naming for these compounds? Or if suppose the branchings are present. Okay, this type of the compound they have given. Then how to write the naming for this compound? Then you have to choose the lowest ring, right? Lowest ring, and substituent in that lowest ring. If the substituent is there, that substituent should get the least number. Here this is 1, this is 2, and this is 3. Here you will get the confused to write the or to choose the numbering. Then you have to choose the numbering in such a way that alkene should get the least number. What? Double bond should get the least number. If you go it from here, here 4, here 5, here 6 and 7, and here it is a 8. Then here it is getting 6 and 7. But if you go it from here, 4, 5 and 6. Here it is getting 5 and 6. And here it is a 7, and here it is a 8. Now this is a correct numbering. Now write the what? IUPAC name. Here it is a bromo, and here it is a ethyl. First will come with a bromo, right? In the alphabetical order. So 7 bromo, and 1 ethyl, 7 bromo, 1 ethyl, Spiro. How many carbons we are having? 2 comma 1, 2, 3, 4, 5, right? 2 comma 5, 2 comma 5. Total oct. Which carbon at which carbon numbering the double bond has started? 5, right? 5 in. Clear? 2 comma 5 oct 5 in. This is a naming for this compound. Done? Now here we'll see now how to write the numbering, or how to write the IUPAC names for our names. Same if our name, my name is Navin, right? Then how to write the IUPAC name for my name? Now let's see. My name is Navin, right? N. This is N. Now here the N, what is the naming of this compound? This is the naming of this compound. Here name of this compound is 1, 2, 3, 4. This is butane. This is a butane. Done. Next. This is a A, right? This is a A. This is A. Now how to write the naming of this compound? Now this is a cyclopropane ring, right? This is cyclopropane ring, and these two are the substituents. Now you see here 1, here 2, here 3. So 1 comma 2 dimethyl, 1 comma 2 dimethyl cyclopropane. Done. Next V, right? Done. V, it is simple propane. Simple propane. Done. Now next, sorry, in the one page it has not came. Then next one is a E. What is the E here? Here 1, 2, 3, 4, 5. Longest carbon chain, right? And 3 is a methyl substituent. Then it is a 3-methyl pentane. And the next one is also E, same. and the last one is a N. Last one is a N. So that is a butane. This is a butane. In the chemistry, how I can give my IUPAC name for my own name? Now in the first one is a butane. Now we have seen here, right? One is butane, 1,2 dimethyl cyclopropane and propane and 3-methyl pentane and butane. Now in the same way, you also try your name with the IUPAC name. Now what is the IUPAC name of your name? That you just comment in the comment section. Just I will cross check over there. Now next we'll see with the another lecture.